the kinetic energy has a positive sign? Because you know that kinetic energy is arbitrarily chosen as positive with positive sign. Why? Because you know to keep in mind that kinetic energy is equals to half mv square and mass is always positive. And the square of any number, if you can take the velocity, the square of any number which is negative, it is always gives you positive. So mass is positive, velocity is also positive, square of any negative number is also positive. So we can say that kinetic energy can never be negative. Okay. But potential energy have the negative sign. Potential energy have the negative sign. Got it? And it is twice. It is twice, exactly twice the with the negative sign, but exactly twice the kinetic energy. Got it? Got it?
Yes, sir.
So there is a relationship that when we move the kinetic energy as we go, come closer to this one, we can say that E kinetic energy will be, I mean the kinetic energy of electron will be more in the, you see that when we have electrons and okay, and like we are just having a ball and we rotate it like this way, so it will just roll and you will so see that when it goes into the hole, then it will move very, when take a very faster rounds. Okay. Have you done this one? That we have a like we have a cloth, okay, and we just place a mass here and just it form a cone like structures, and when we throw a coin or a ball over it, so it will spiral like this way. So you see that the object, if the object is closer to the nucleus, then its kinetic energy will be more. So kinetic energy will be greater in the K shell, then L shell, then M shell, then N shell. Okay. But if I talk about the same thing, if the kinetic energy is greater in this one, so you say the potential energy will be less, because if kinetic energy will be more, then potential energy will be less. If potential energy is more, then kinetic energy will be less. So we can say that E potential energy of electron will be equals to, will be greater in the, we can say it will be less in L, then M, then N, then N shells. Okay. Got it? As we move further. Got it?
Yes, sir.
Next, if I move further, that if I talk about the E total energy, now you know the total energy is E kinetic energy plus E potential energy. Okay, now you see that it is half of KZE square, means half. If you means you know that this is exactly half of this one. So we can say that E total energy will be equals to half KZE square by R, and that is equals to E total energy. E total energy will be equals to minus 13.6 into Z square upon N square electron volt per atom. You need to keep in mind that one thing, that E total energy has the same value in numerically, it has the same value that of kinetic energy, but kinetic energy has positive sign here and the total energy has negative sign. Why? Let me explain you. Let I'm saying that the kinetic energy is X, positive X. Okay. Then this potential energy will be twice of this one, but in negative sign. It will be minus 2x. Are you getting my point?
Yes, sir.
If I'm saying the kinetic energy is X, then the same potential energy of the electron will be twice of this one, but of with negative sign. With negative sign. Now you know that total energy of the electron is kinetic energy plus potential energy. So this will be kinetic energy is plus X plus minus of 2x, you will get minus X. So what you are getting here is that kinetic energy, total energy is same as kinetic energy, but with negative sign. But with negative sign. You understood?
Yes, sir.
Sure.
Yes.
Okay. Now let's move to the next part is, now you need to understood one thing, that the total negative energy of electron means if it is negative, negative since total energy is negative. The total negative, if the energy is negative means if the electron is actually having negative energy, I told you the maximum energy an electron can have is 0 at infinite distance when it is not experiencing any charge. So if electron is experiencing any charge or if it is positive, okay, so we can say that if the total energy of the electron is negative, it means it is binded with the nucleus. It is under the influence of nucleus. Okay. Got it? Because the electron can have maximum energy when it is not in which is zero, which is not negative, if it is not under the influence of a nucleus, if it is not under the influence of a positively charged nucleus. Got it?
Yes, sir.
So if I write it here that the total negative energy of electron shows that electron bind with the attraction force of nucleus. Electrons bind with attraction force of nucleus with that amount of energy, amount of energy. Got it? So if I
Yes,
talk
sir.
about that, what is the ratio of the total energy is to kinetic energy of electron is to kinetic potential energy of electron. So what should be its ratio? Tell me. Tell me. These two are same. So we'll say that -1 is to 1 is to -2. Are you getting?
Yes, sir.
Okay. So this you need to understood. You need to write it down. Then we shall be moving towards the numerical problem regarding to this one. Okay. Just a minute. Let me find out the numerical. Let's study the ionization energy of the electrons also. Then we shall be moving towards this. Okay. Now last topic for this one is ionization energy. Ionization energy. What is ionization energy? Tell me. The energy required to remove an electron from the outermost shell of an atom. Okay. Isolated
Yes, sir.
gaseous atom. So this we have the energy required to completely removal of an electron from the ground state. Okay. From the ground state. So we can write here that the energy required to for complete removal of electron from ground state. Okay. So for example, if I'm having this is the N1 is the first, it is the ground state. Okay, and this is the first shell, then it is the second shell, then it is the third shell, then fourth shell, then fifth shell, then we are just moving it to infinity, where N is infinity. Okay, so we are just making this one that this is the first excited state, this is the second excited state, this is the third excited state. So we are just taking the electron to this level, where its maximum energy is 0. Got it? Got it? So ionization energy will be equals to, if I talk about the ionization energy will be equals to the energy of electron at infinity, the final energy of electron minus the, means if I want to know that what is the energy being required. So for example, if it is at 50, now it reaches at 100, sorry, 150, then what is the energy being required? 100. Got it? Got it? So what we do here
Yes,
is
sir.
that we always final minus initial. So final energy of the electron is at infinity minus the initial energy of the electron. Got it? That will be equals to 0. You know that infinity, the maximum energy of electron is 0 minus 13.6. That will be into Z square electron volt. Got it?
Yes, sir.
And if we are considering n, because we are just writing n square upon z square, so we are just considering here that n is 1 because it is at the ground state first. Okay. Got it? So that will be positive 13.6 Z square electron volt. Got it? Z is the atomic number of the element. Got it? Now the ionization energy is always equal to the kinetic energy of the electron in the first shell. Okay. So we can say that it is always equals to the kinetic energy. For what is the kinetic energy of the first shell? Same. Okay. So we can say that ionization energy of electron is equal to kinetic energy of electron in first shell. First shell. Okay. Got it?
Yes, sir.
Note it down, please. Done?
Yes, sir.
Okay. Next, if I write a question here, the ionization energy of hydrogen-like species or hydrogen-like atom is 14.4 electron volt. Find the amount of energy released when electron shows show transition from fifth to first orbit, from fourth to first orbit. Good. So let me help you that how you are going to do this one. Now this one you should see that electron is actually in the fourth shell, okay, and it is need to come in the first orbit. It need to come in the first orbit, okay, first orbit. So electrons means we need to find out that what is the energy being required. So some of the energy that it is in the first shell, okay. Now the electron is coming from fourth to first. So first it will come in the third shell, and then it will jump to this one, okay. Got it? So let you write here is that the electron is jumping from n is equals to 4 to n is equals to 1. Got it? So what you are going to calculate, you will going to calculate the value. That is 1.13.6 into z square upon n square, where n is the target, means where it is being. Okay, so we will going to write here 13.6 into z square. Z is hydrogen, and this is the z is actually the atomic number. Okay, so the atomic number of this one, because it is saying that hydrogen, okay, and this is given to you Z upon. So ionization energy of hydrogen like atom is there. Find the amount of energy released when electrons show the transitions from fourth to first orbit. Okay, so we'll write here n is the four shell. We'll write here 4 square, and this value is given to you how much? E4. Tell me. E4 it is given to you how much? That this one. Okay, when this is showing this transition, so it is giving you 14.4 electron volt. Got it? So what you are going to get here is 13 minus 13.6 into z square upon 16 is equals to 14.4 electron volt. So when you solve it, what you are going to get? Tell me. Energy. And here, if we are having this one, the energy of first shell will be minus 13.6 into z square upon 1 square. So you will get minus 13.6 z square upon 1. Got it? So here we see that this value, this is the E1. E1. This value is given to you. This is the energy of the first shell. Are you getting this one, Noah? Or it is going, are you understanding this one?
Yes, sir.
So we will write here that 13.6 is equals to z square upon n square. You write it here minus 13.6 into z square upon this one. Then you open this one and you find this value, that this value is given to you as means this value is almost given to you, that energy, the ionization energy. So ionization energy is always equal to the first shell energy. Okay, the energy of the first shell. So we write this one. We write this one as 13.6 into z square. This is the energy of the first shell. Just energy of the first shell. Okay. So you know that the ionization energy is equals to the kinetic energy of the first shell. Okay. We mark this one. That ionization energy is equals to kinetic energy of first shell. First shell. So what you are going to write here, that this is the kinetic energy of the first shell minus 13.6 into z square upon n square. This is the energy of the first shell. So you write it here that 13.6 into, instead of this in the fourth shell, you write here you write this value is given to you. Okay, this is equals to 14.4. So right here 14.4 upon 16. Got it? Then you will get 0.9 electron volt, minus 0.9 electron volt. So this is the energy. So how much energy is being released here? Can you tell me? Can you tell me? Let me explain you one more time this question. Let me explain you that the ionization energy of hydrogen atom or hydrogen like atom is this one. This is being given to you. So what it is given to you? It is actually given to you the kinetic energy of the first shell. First shell, because ionization energy of the first shell, or we can say the kinetic energy of the first shell, is equals to the ionization energy that we have done here. Ionization energy of the electron is equals to the kinetic energy of the first shell. Got it? Got it? No, huh? Got this one? Hello? No, are you there? Hello? No, are you there? You are muted. No, huh? Are you there? No, are you there?
Yes, sir.
Why you are muted? I'm asking you. So let
Sir, I was unmuted, but my
okay, let me explain you one more
microphone
time.
was not.
Okay, let me explain you one more time this question. that ionization energy is always equals to the kinetic energy of the first shell. Okay, kinetic energy of the first shell. Got it? Because we are just removing the electron from infinity, from first shell to the final shell. Okay, the energy required to complete the to complete remove the electron from its ground state. Okay, from its ground state we are talking about, and ground state is the first shell. So we are just taking the energy. So we always write here that the ionization energy is always equals to the kinetic energy of the first shell. Now in the question, it is being asked that ionization energy of hydrogen-like atom is 14 electron volt. So what it is given actually, it is given to you that it is the kinetic energy of the first shell. Okay. Now find the amount of energy released when the electron show transition from fourth to first orbit. Find the amount of energy released. How much energy is being released when, because electron is coming from outer orbit to inner orbit, so it is going to have higher energy in this one, and it is coming to the inner orbit, so it need to release the energy. Okay, as it is coming into the first orbit. So found the energy released when electron showed a transition from fourth to the first orbit. From fourth to the first orbit. So we will first of all find out the value that we will write it like this way, that uh, ionization energy of the first shell is actually equals to minus 13.6 into z square upon 1. This is the ionization, this is the kinetic energy of electron, and that is equal to the ionization energy of the first shell. Ionization energy. This is also equals to ionization energy. Okay, and it is being given to you, that is 14.4 electron volt. It is being given to you. So we actually can write that minus 13.6 into z square is equals to 14.4. Now we need to find out the kinetic energy of electrons of the fourth shell. Kinetic energy of the electron of the fourth shell. The fourth shell will be equals to minus 13.6 into z square. We don't know the atomic number, so we write it like z square upon n square. So what is n? N is fourth. So we will write here 4 square. So you write here minus 13.6 into z square upon 16. Now what you are going to write here is this 13.6, and this value is actually equals to 14.4. So you write it 14.4 upon 16, you will get 0.9 approximate with minus sign. Okay, with minus. Okay, got it?
Yes,
Got
sir.
it. Now, what is being asked, that the ionization energy is given to you. Ionization energy is given to you of the fourth shell is 14.4 electron volt, and the ionization energy of the first shell is given to you. That is also equals to the total ionization energy. We can say that the electron is going in the fourth shell, it is going to have this energy. This energy. Okay. So if the shell is going to have this energy, so the if when it comes to this one, when it come back to the first shell, then it is going to release that much amount of energy. So the change in energy will be equals to the energy, the ionization energy, the we can say the final energy minus initial energy. Okay, final energy means when it is was in this one, so it was minus 0.9 electron volt minus 14.4 electron volt. So you will get this one as plus of 13.45 electron volt. You might, do you understood this one?
Yes, sir.
Sure.
Yes.
Okay, so please note it down. Change in energy we need to find out. Na? Final energy of the fourth shell is this one. And this is the initial energy of the first shell that is given to you. This is the initial energy of the first shell. Okay, that is given to you. So fourth shell minus first shell, you will get this one. Note it down. Done this one?
Yes, sir.
Next question. Kinetic energy, kinetic energy of electron in third orbit of Li2 positive is x electron volt. Find its potential energy of electron in second shell shell of Be3 positive. Do this one. You need to find out the value in terms of x. This is easy question. Try to solve this one. Are you solving?
Yes, sir.
Got the answer?
Sir, could you explain how to do this question again?
Okay, yes, I'm going to help you. What you are going to do here is that first of all, it is being given to you that the kinetic energy is minus 13.6 into z square upon n square. So minus 13.6 into z for the what is saying third shell. And z is the atomic number for lithium. Lithium has atomic number 3, so 3 square upon third shell is 3 square again. So what you are going to do, minus 13.6 is into 9 upon 9 you will get. And this is the kinetic energy is x electron volt. So what you are going to get, that x is equals to minus 13.6 electron volt. Okay. Got it?
Yes,
Now
sir.
find the potential energy. Now you know that potential energy is twice of this one, but with positive, sorry. Here we don't have minus sign in this one. In the kinetic energy, okay. Actually, we arbitrarily choose this one that since the kinetic energy is positive, okay, kinetic energy of the electron is being given to you, that is minus 13.6. We always write this potential kinetic energy with positive sign, okay. Now you know that this is the value of the kinetic energy. Now you know potential energy. Potential energy is same twice of kinetic energy, but with positive sign. With sorry, but with negative sign. Got it? Got it? So
Yes,
that's
sir.
why we will write here minus 2 times. Then we will write 13.6 into z square upon n square. So minus 2 times of potential energy is minus 2 times of the kinetic energy, but with negative sign. Got it? So what you are going to write it 13.6, this one. Got it? Then uh, z square for this one. Second shell with beryllium. Beryllium has atomic number 4. So right here 4 square upon second shell is 4. Second shell. So n is number of shell. So right here 2 square. Got it? You know that you have calculated that this value is minus 2 into 13.6 has the value of x. So right here x into 16 upon 4. Got it? You got it? You will get 16 for the, then you will get minus of 8x. 4 to the 8x. Potential energy is 8x. In terms of x, we need to tell. Okay. Got it?
Yes, sir.
Okay. Next question. The energy of an electron from when it jump from second to third orbit. Second to third orbit is 47.2 electron volt. Okay, what is being given to you? That the energy of electron from when it jumps, energy absorbed, you can say, by an electron when it jumps from second to third orbit is 47.2 electron volt with with nuclear charge. Nuclear charge is given to you, that is positive Ze. That is the atomic number. If energy of electron in the ground state, if energy of electron in the ground state, the ground state of hydrogen atom is minus 13.6 electron volt, then find Z. We need to find out the atomic number of this element. This is very simple question, Stanley. Try to solve it and then I will help you. Try to solve it, then I'm going to help you. Are you solving?
Yes, sir.
Did you get the answer? What is actually that I'm going to help you that what is actually this 47.2 is given to you. The energy of electron when it jumps from second to third orbit. Okay, so this is given to you, that is 47.2 electron volts. So it is actually 47.2 is the energy of electron when it jumps from third to second orbit. Okay, third to second orbit. Now you know, either you can write it. What actually this means? If the energy of electron in the first orbit is 13.6, it is actually nothing is given to you. Means this is indirectly means mentioned to you that we have means when we have E is equals to minus 13.6 and we have hydrogen atom, it is saying. So first hydrogen atom has only one shell. So atomic number is 1 and also 1. So this is indirectly saying that this value, that E is equals to minus 13.6. So we can write it with the formula here also, that it is equals to 13.6. We will write 13.6 into z square upon n square minus 13.6 into z square upon n, where n is given to you in both the cases. Here it is 3 square, 3 square, and here it is 2 square. Got it? Got it? You
Yes, sir.
understood? Now you will get here my 13. Okay, you will get here 13.6. Okay, you will get here 13.6 into z square. You need to find out to take the z square as common, and you will get here 1 by 9 minus 1 by 5. You know this value is greater than this one, so you will get the negative sign. Okay, so that's why we have we will put this value as with the negative sign, because it is given to you that this has minus 13.6. So right here minus 13. So when you get this value, you will get the positive sign. Got it? Because when you are going to get it on, you will get LCM as 45. So you will get 5 here and 9 here. So you will get minus 5. You will get 45 upon 5 minus 9. You will get minus 5 by 45, that you will get. Sorry, what you are going to get here is when you reciprocal this one, you will get 9 5. Sorry, it is not 5, it is 4. It is 4. When you put it, you will get 2 square, that is 4. So you write here 4. Okay, then it will be 4. Okay, and the LCM is 4 9 the 36. So you'll get minus 5 by 36. Got it? Are you getting this one?
Yes, sir.
Minus 13.6 into z square into what you are going to get here is minus 5 by 36. Then this minus minus will get plus, and you will get the value when you multiply, and this is 47.2. So this 13 will comes down. Okay, this 47.2 upon 13.6 upon 13.6, and this minus sign we are just multiplying here is equals to z square into 5 by 36. Okay, this 36 will also goes down, and this 5 will comes down. So we are going to have z square is equals to 47.2 into 36 upon this 5 will comes down along with 13.6. Okay, got it? Got it?
Yes, sir.
Now, what value you are going to get it when you are going to multiply this one and when you solve this one? So when you cut this values all, so you will get approximately that will you will find this is 47.2 and this is 13.6. So 13 on the 13, 40. This value will be approximately equals to divided with this one. Okay, 13.6 and 14.2. You have to actually multiply this one. So when you is there any number which you can cut it? 13.6. So when you multiply this one, what you are going to get? 13.6 into 5. Add in 13.6 into 5. 6 5 the 30. 0. Okay, 13 5 the 65. 65 and 3. Okay, first you have to cut it. Let me do it with the calculator. Just a minute. So when you multiply 47.2 into 36. Okay, you will get 16,699.2. And when you multiply 13.6 by 5, you will get 68. So when you divide it with this one, 1699,